Hi, welcome to Farnet Pi videos. I'm DC here, and in this video I'm going to show you how to use Move Lean SLA66R01L NFC tag, and this is a product from Infineon Technologies. So these are some of the features of this tag. This is a ISO 1443 Type A tag, and which is also a NFC Forum Type 2. Now some of the applications of this tag, and this I got from the documentation of this tag. These are the public transport, the water parks, the leisure parks, and in general you can use these tags for any single or multiple entry ticketing system. So this tag doesn't have any password or authentication, and it's pretty open. So you may be thinking how these tags are secure when they are used in applications like a transport or a ticketing system. So most likely in these type of tags there will be some kind of a application side or a system wide security in terms of encryption and decryption that uses some of the concept like the key diversification and the encryption or decryption using the AES or 3DS cryptographic keys, etc. The next thing is you'll be asking where to buy these type of tags. Now, as far as I know, I could not see any website where you can buy few of these tags, maybe 1 or 5 or 10. However, if you visit the AliExpress or the Alibaba.com, you can buy probably the minimum quantity would be like 1,000. So if you're doing a software project and if you want to use this, probably you'll have already a stock of thousands with you. Now, so I'm going to cover the following things in this video. We are going to understand the data sheet because this is very much required if you want to know what this tag is capable of doing. I'm going to show you how to read and write. You can use any mobile app like some of the apps that are very popular are the apps from NXP, and I'm going to show you how to read and write using the following PC based reader writers. So I have done many videos on ACR122U and PN532 based reader writers, and the OmniKey, this is also one of the popular reader writer there, and Keyduino development board, this is based on the PN532 chipset, and also the CR95HF based reader writer. So what I have noticed is, so this tag, the MyD tag, is more or less similar to the Mifare Ultralight tags from NXP. So I'm going to show you, we are going to compare the documentation of MyD tag and the Mifare Ultralight tag. Then I'm going to show you how to do the read and write. So what we know so far is this tag is manufactured by the Infineon, and you can visit the product website, and this is the one. If you look at this page, there are 3 tags available here. The one we are interested is this SLA66R01L, which is also called MyD Move Lean. So this is my first experience with this card, so probably I'll be just reading out whatever word you see on the screen. Now this tag, as you can see here, it has got 48 bytes, and now it has got some of the features here which for me is very similar to Mifare Ultralight. And there's also another tag called MyD Move, and this has got a kind of a password protection. So this reminds me of Mifare Ultralight EV1 kind of tag, or maybe Mifare NTag 213, because this has got more user memory, and also I got one more My-D Move NFC. So we'll be interested in this. When you click here, this will take you to the product page, and it's very easy. If you go through this, you'll come to know some of the features of this tag. So I'm not going to read this out because I know this tag is is very similar to Mifare Ultralight. I'm going to directly jump into that, the data sheet now. Now if you scroll down, now you'll come across access data sheet. If you want to know more about this, if I were you, I would have read all these documents. So I've gone through this data sheet here. If you click, it will take you to this PDF. Now this is a must to read document, and this is the document is pretty easy to understand, and I'm just going to go through some of the important pages in this document, and also going to open side by side the Mifare Ultralight document as well. So if you scroll to page number 10, this is the memory organization of the MIDI tag. So there are 16 pages altogether, and each page has got 4 bytes. Now the first four pages has the UIDs and the static clock and the OTP, and the remaining pages, this is for the user data. Compare this with the this Mifare Ultralight tag, and here also you can see that the first 4 pages has got serial numbers, the locks and OTP, and they're exactly in the same position as well, and the remaining pages from page 4 to page 15 are for the user memory. There is a difference in the UID. So this tag has got a 7-byte UID, of which the very first byte, the UID 0, has got 05, which means this is the manufacturer code. So 05 means this is this belongs, or this is made by Infineon, and the remaining bytes, there you can take this as a number, whereas in this case the document says in the UID 1, the higher nibble tells you the IC family. So you can if you remember, I showed you about 3 different products of MIDI. Probably you can see a different numbers in this higher nibble. So I don't have access to any other MIDI tags so far. As and when I get those tags, then I'll be making videos as well. So that's the one difference here. The next, you can see the command set, and in fact if you scroll down, the OTP and all the locking mechanism, these are all the same as Mifare Ultralight. So what I'm trying to say here is, if you already worked with Mifare Ultralight, then you can understand the document very, very easily. If you scroll down further, you can see this is the state diagram, how this tag works, right from the power on to the activation, anti-collision, and there shouldn't be any difference between in this diagram, because this is not specific to any product. This is specific to the standard. So both MIDI and Mifare Ultralight, they both belong to ISO 1443 type A, so obviously they should be the same. Now here, this is the list of commands supported by the MIDI. You got read block, write block. These are reading a single block or single page. Sorry, this is read, this reads 4 consecutive pages. Write block, this is to write one single block or one single page, or writing 4 bytes. And you also have the compatibility write command, which writes which sends 16 bytes, but only 4 bytes are written. These are the 2 commands which are not present in the Mifare Ultralight tags. So this is the read 2 blocks, where you can read 8 bytes, whereas the first read command reads 16 bytes. So I'm not sure how what's the main purpose of reading 2 blocks, and so these commands are there. So we as a developer, if you find this useful, then you can use it. So writing 2 blocks, this probably has advantage, because if you want to write say 2 pages at a time, if you use this command, you'll end up sending the command twice, whereas here a single command can write 8 bytes. Now these are the 2 commands which are not present in Mifare Ultralight. So that's the only difference, okay, in the command set. If you scroll further down, this diagram shows you the command structure. So this is a read command, the command code 30 followed by address followed by the CRC. So this command structure is exactly similar to the Mifare Ultralight. So the response is, again, you get 16 bytes followed by the CRC, or you get NAK. So what I would like to mention here is, so more or less, MID and Mifare Ultralight tags, they're more or less similar. So as I mentioned before, it's not easy to buy these tags from internet in few numbers. I have received a card from one of my the users of the software, and I got one, and it says it's MID and Move Lean. So I'm going to use this NXP Tag Info app, which is running on my Android phone, and you can see here, and this app I use most often because it's the quickest way of finding out more information of any unknown tags. Here the tag info app says this is MID Move Lean SLA66R01L. Now you got other information. You can see whether the tag has got NDEF. So this particular tag doesn't have NDEF. You can see any extra information here, or you can see the full scan. Now this is the content of the 16 pages. Now looks like this tag is been used for some purpose. So let's not worry about where this tag is used. So what we need to know now, at least we have got one MID tag to play with. So now we are sure this is the MID tag. So next I'm going to show you how to use this tag. So what you see here is I've got ACR122U reader writer connected, and I'm using this ACR122 Made Easy software. There's no changes made to this software yet, because I'll be using this MID tag just like a Mifare Ultralight, because we know now. So I can use the Mifare Ultralight command to read and write. So even though you cannot read 2 bytes or 2 pages or write 2 pages ahead, probably in the next release you're going to say the Mifare Ultralight stroke MID Move Lean very soon. So I'm going to choose here, and I'm going to activate. If you look at the commands which has been used, now you have come across these commands in all my previous videos. I'm going to take out the ATR from this screen, and if you have been playing with the NFC tags, I'm sure you'll be familiar with the this ATR, this website, where if you type the ATR, this will tell you what type of tag is that. Again, this is a very straightforward decoding of these bytes. So there are some documentation and maybe tutorial you can find that teaches you how to decode the ATR. Now what this website says, this is of type the Mifare Ultralight. So you can see now how the way these bytes are decoded here. So this says it's a Mifare Ultralight. Still, I'm not very, looks like we know this is not a Ultralight. This is a MID from Infineon. Now, not very sure, why we got this ATR. So the ATR is generated by this device. So I'm going to show you one more device where it gives a different ATR. After that, we're going to start doing the read and write. So I have connected the OmniKey 5421 reader writer, and I'm using this software. And if I choose this contactless interface and choose the Mifare Ultralight, I'm going to place this tag here, say activate, and this gives me a different ATR altogether. And if you look at the commands, I'm using the PCSC, the ATR command. That's the WinSCARD lib SCARD state. If I take this string and go to the ATR string website, submit another, Now with this ATR I get completely a different information. It says it is a MIDI Move SLE66 R01P. In fact, so I'm a bit confused now why we get a different ATR from the OmniKey device. And the thing is, who do we trust? Whether to trust my mobile phone that says this is Move Lean, or to trust the ACR122U that says it's ultralight, or to just go with what the OmniKey says. It says it's the MIDI. It's a different, completely it's a different tag altogether. So again, we have to decide. So I would go with what the mobile phone says. It's MIDI Move Lean. So we are back into ACR122 redirector now. Going to choose the Mifare Ultralight, activate. So it looks like the connection is not done correctly here. So choose this and say activate. Now, so I'm going to reconnect. Okay, looks like to restart this software. Oh, I'm sorry for that. I had a few white colored cables in front of me. I was trying with the wrong reader. Okay. So as soon as you place this tag on ACR122U, you should hear the first beep sound. So you can see that this is the 7-byte UID, and the first byte of UID is 05. This indicates this is a tag manufactured by Infineon. Now if you say read the tag, so as I mentioned before, this tag probably has been used for some purpose which I'm not aware of. Now this is the content of this tag, and you can see some of the important features are, so nothing is locked. So let's pretend for a while this is a brand new tag. Now in a brand new tag you will find, now from page number 3 to 15 you would find either all zeros, or if this is already formatted for NFC forum type 2 tag, you will find the initial empty NDEF record set into this OTP. Is also called the capability container. So let's forget about the content of this tag. So you can see here all this the read address. These read commands are not specific to the MIDI, because you have seen the MIDI command set. This is a PCSC standard read command. It's called read binary command, which is FFB00010 so on. And these read commands reads the entire content of the tag. So I'm going to try writing something here. I'm going to clear off this data from page 4 to page 15. So I'm going to set this to 0 and write. Now you can see the write command is called update binary. Again, this is a PCSC command. Using update binary command you can write the individual page of this. So however, this MIDI tag does have writing 2 pages at a time. If you look at here, I have used more or less 11 write command. If I had used write 2 bytes or 2 pages, I could have reduced number of writes. So which probably you're going to see in my next release of this software. Now read and write is working all right. So there's nothing special about working with the locks. Lock eventually, it's again when you try to lock a page, what it does is it makes the page read only, and it also changes the content of this the log bytes, which is marked in yellow. And I'm going to log page number 4, right? Now this log page number 4, if you try to write something to that, so not this, write 100,000. Okay, so the software doesn't let you write because this is locked. Probably click hitting this will let me to write, say write. Now looks like the write is successful. However, if you try to read, okay, so even though now write looks successfully, now when you try to read back, you got back the old value. So try doing this again. Number write, or probably the best thing is I'm going to reactivate the tag. So write to page number 4, which is locked. Go to strict mode, set it off. So it looks like it's successful, but I know it is not. If you try to read, you read back the old value. So you cannot write in to a lock page. Now other thing is changing with the OTP again, because this software, this screen is Mifare Ultralight screen. I made so many videos on Mifare Ultralight. You just have to put a tick here and write the OTP. OTP is written. So what we just saw is using the same Mifare Ultralight screen, you are able to read and write to the MyD tag as well. Now next I'm going to show you use a different reader writer, that's the OmniKey 5421. Okay, here we have OmniKey software. I'm going to activate, and here the UID is in a different order. It's the 05, it's supposed to be here. So if you try to read, so I'm not able to read using 5421. It is because I don't know the exact reason, but what I think is this is the ATR detected by this OmniKey reader writer, and I think OmniKey reader thinks this is a different tag. This is not a MyD Move Lean tag, and that's the reason why the read command fails. And if you look on internet, the response code 698C, it says it means the command not supported. So I'm sorry, you cannot. I don't know why. Probably now I'll send a request to the support of OmniKey and let you know what exactly is the problem here. So here I've connected a PN532 board, and this is the software called PN532 Made Easy, and this is again the same software you have seen in all my previous videos on PN532. I'm going to choose the Mifare Ultralight. I'm going to place the tag and activate and read, and you can see all the PN532 commands used. I'm also going to write to page 5, write. So hit this write button. So the write is successful, and you can see now the write and read. These are the PN532 commands that are used here. So again, you don't see the card specific command here. So this is again the command set that belongs to the PN532 firmware. So if you want to see the card specific command, I'm going to try the use compatibility right here. Now next I'm going to write this page. Before I write, I can put a tick here, activate, telling the software to use the compatible write mode. So I'm going to change this to 200,000 and hit a write. If you look at here, this is the compatibility write command. which is done using, so again, here also it's using a command that's part of the PN532 firmware. Okay, so what we just saw is you can use MID Move Lean tag using the PN532 board as well. So next I've connected the CR95HF discovery board, and this is a software we have been using before. So I'm using this software called Understand RFID using CR95HF. I'm going to choose the Mifare Ultralight. I'm going to place the tag, activate. Now here you have to be a bit careful, how you place this on, where you place this tag. Oops, there's something wrong with this. Yeah, I got this thing. Now this is the UID, and I can read the tag. Okay, yeah, I can read the tag, and I'm going to show you. If you look at the commands that are used here, these are the very low level commands. Like you can see, it starts from REQA, anti-collision, select, and antenna off, and so on and so forth. And if you look at the read command, these commands are very specific to the tag itself. You can see the 3000 is the read command. If you look at the documentation of this MID, so it's a 3000. And using the CR95HF, you're able to see that all these card specific commands. And I'm going to write to page number 7. Right. If you look at the write command, again this is A207 followed by the data. And if you look at the documentation, the write command is A2 followed by the address followed by the 4 bytes of data. And I'm going to try one with the compatibility right here, this one. Go to page 8 and I'm going to key in some random number. Right. And if you look at the write compatibility, you got two parts there. Part 1. So part 1 says what page number are we writing. It's a A0 followed by the page address. And the second command is the 16 bytes of data. So even though the 16 bytes are sent, only the first 4 bytes are valid. The remaining 12 bytes are set to 000. If you look at the command set, the command structure, this is the one. You can see that A0 followed by address, and the second part is all the 16 bytes. And see this CRC, which the software doesn't have to compute. In RFID reader at a chip, auto computes the CRC. So I think that's all about MID. So what you saw in this video is about the MID. You're able to read and write, and MID's Move Lean is compatible to Mifare Ultralight, and you're seen you're able to read and write using A722U, using PN532 reader writer, and also using CR95HF. However, we couldn't get the read and write done using OmniKey 5421. Alright, thanks for watching.